Okay, hello guys. I can already see a few of you, so we'll just give a few minutes to others who are being late for today's webinar. So just yeah, like 1 minute maybe.
Sure, but let's not wait longer than 1 minute because everybody who is on time should deserve to have a reward.
Okay, guys, let's start maybe.
5 seconds more, guys, and we can start. Just, for 1 minute.
Okay.
And that's it. Okay, so we should start now. So guys, welcome to our Data Storage MythBusters series of interactive webinars. Happy to see you here today. We've been preparing this webinar really long for you to bring really valuable knowledge. So thank you for visiting us today. And together with DIAWAY and LizardFS, we should start. And so what will be happening today? So next 45 minutes, we'll discuss various cold archive data storage myths from software and hardware, and of course, economical angles. And maybe I'll tell it already. So at the bottom of your screen, you have Q&A button, and feel free to add your questions there. We'll have a Q&A session in the end of our webinar, and we'll answer every question of yours. So before we move on to our myths, maybe a few words about today's organizers. So DIAWAY. DIAWAY is global big data storage integrator. And DIAWAY designs, deploys, and optimizes data storage systems for huge enterprises. So for example, DIAWAY helps leaders like Acronis, Cloud Linux, Brush Files, Rike, and many others. And DIAWAY is also an official partner of AMD, of Western Digital, of Juniper, and other global hardware and storage vendors. And LizardFS. So LizardFS is software-defined file storage. It was originally inspired by Google FS. So LizardFS offers allows you to combine disk space located on several servers to one namespace visible by Unix-like or Windows-like systems like usual external disk. And LizardFS is basically used by either individual users as well as by huge enterprises all over the world. And as for today, from what we know, the largest cluster running on LizardFS has several exabytes of cold archive data. And my name is Anton Borecki, and I'm Business Development Manager at LizardFS. I'll try to organize this webinar today so it has some structure. And guys, maybe a few words about you, Neutrino and Dima, please.
Sure. So, hi everyone. It's very nice to meet you. I am Neutrino, and I am actually creator of LizardFS. And from my side, I can just tell that I have 20 years experience as a system engineer. And I started with the really huge companies like Siemens or Google, and then I moved to the smaller businesses, and LizardFS is let's say my baby. I created it, right? So I'm very happy to be here with you.
Thank you, Neutrino. Dima, a few words about you.
Hi, everyone. I'm Dmitry, and I'm co-founder of DIAWAY. And before DIAWAY, I had like 15 years experience in mostly in telcos and software companies and service providers as well. So that's basically it. Let's start the webinar.
Yeah, but maybe thank you guys for introducing yourself. But before we go on to actual busting myths, maybe Dima, maybe you will tell our audience what was the reason for organizing this webinar? What knowledge, what values are we trying to bring to our community?
Well, there's a fact that around 90% of companies that lost their data center infrastructure for 10 days or more actually filed for bankruptcy within 1 year of the disaster. And that literally means that the survival of businesses depends on how the data storage that keeps all the data is organized. And that's why we have created the Data Storage MythBusters series of webinars. And that's the reason to discuss cold archives storage.
Cool. Thank you.
Because there's plenty of myths about it.
Yeah. Thank you for the intro, Dima. So it seems to me that this topic is really important from what you say, 90%, like really, really a lot. So now let's move on to our first myth. So LTO Archive can safely store data for 30 years. So gentlemen, what about this first myth? Is there a real chance to store archive data forever, or is it just a marketing that people try to sell us? What's your opinion?
Well, this is for sure something which the companies are telling us, that you can store the data for, let's say, 30 years on the tape. By the way, I have tapes with me here. I have 2 generations, LTO 4 and LTO 6. And I need to tell you something. I love them. I like them very much. As a nerd, I like the technology which is behind it. It's really cool. It's just important that we, despite this, how much we like the tapes, we also think about this when we should actually use them and when we should not, right? And regarding this myth, which is that you can store the data for 30 years, we should actually look at the warranty of the hardware which is attached to any storage system. And usually this warranty window is 5 years. And which actually is the same as, for instance, for the hard drives, it's also 5 years, right? I'm sorry, but we just lost the screenshot.
Deck, yes.
Am I back, guys?
Mm-hmm.
Yes, you're back, but the deck not.
We don't see the presentation, you know, Anton. Can you try to share the screen again? I think we lost him completely. Something happened on the network on his side. Oh, he's back. Cool.
Can you hear me now, guys? Is it okay?
I can hear you.
Hopefully, cool. Yes.
Maybe yes, hopefully
let's proceed. We were interrupted discussing the warranty term is the same for HDDs and tapes, and it's actually 5 years.
Yeah, exactly. What I was trying to say that we, as a professionals, we should always look at the both sides on the coin. This is what they write on marketing papers, and this is what is the reality when we actually are building the professional storage system. And what is important here, what I wanted to say is that LTO is actually younger than 30 years. And when you think about this, that they promise something more, and we already know that it's impossible actually to read LTO 1 or 2 with the new generation libraries and drives you are buying, this already is kind of a myth which is busted in this moment, right? It's like, let's focus on reality. Reality is my hardware has 5 years warranty. I am going to stick to that, right? And see what I can do in this window, right?
Piotr, could you please show again the tapes? And actually, I can. There's no chance to read the tape in 30 years just because there would be no reader for that, because there are different standards that are coming, and there's no backward compatibility for several standards. So you can't read like more than 5 years ago standard with modern reader. That's the issue. And the idea behind this slide is if we would really like to store the data for longer term, like 10 years or 20 years, or even longer, we should imply the refreshing process of all the hardware we have. And this will allow us to store the data longer than the hardware life cycle term.
Mm-hmm. Yeah, actually, basically, this is what you see here on the slide from computer science. We all know what it is. This is like first in, first out queue, yes, and this actually applies to the realistic scenario when you would like to build your storage system. And it's very important to make sure that you have warranty for this, what you have in the house. And it's also important to be state of the art, which means the new people which are coming to your company, they actually can understand the technology they are using, and it's not too old in order to maintenance it, right? So, and this is possible when you use something actually else than the LTO, because with LTO, you always have this little elephant in the room, you know, something a little bit different, something a little bit like dinosaur. Even if it's so cool to have it, you know, everybody, I think, should buy it and have it on the desk at least, right? And it's just dangerous to keep your data longer than a warranty window on the hardware you have in your data center.
Okay, sounds like you busted it, right? I let myself move on to the next myth. So this one is about cost efficiency. So LTO is the most cost-efficient technology for cold data storage. So guys, how to drop down the typical cost of your cold data storage for real?
Oh, well.
So I think we should discuss first of all the numbers here. And do you have any kind of estimation for tapes, like what will be the TB cost?
Well, yeah, so
Piotr?
yeah, of course, I make a wide research about this, and I was also using the tapes in the past, so I know how it's looking the reality about the cost regarding this kind of storage system. So if we are talking realistically about the petabyte storage here, you cannot just buy one drive and let's say 100 of this and keep them in the drawer, because you will be not able to maintenance this kind of the storage solution. So actually the only choice you have is to buy something which is called library, and this significantly increased the cost and the price for the first petabyte you are buying. Because you need to think already how many petabytes in the future I am going to have in my storage. If you accidentally buy something too small, like only with, let's say, 2 drives inside library, suddenly you will hit the limit of the maximum capacity of growing this library because of the manufacturer limitations. So it is actually, when we are talking about multi-petabyte storage solution, we are looking at $1 million for 5 petabyte storage on the start. And then maybe the price will go down, or maybe not, because you have never this warranty. But for sure, on the beginning, you have a fixed, constant cost of buying the library.
Well, speaking frankly, I was under the impression that the initial investment for LTO is like less, and TB cost is like lower than probably other alternatives. And I can share the screen just to show how we call it Techonomics of scale-out software-defined storage based on HDDs, actually not on tapes. Let me try to.
I'll stop sharing my screen then, so that everything works. Okay.
Okay. Can you see my screen? Is it okay?
Oh,
so,
yes, I can.
So the idea is I won't pick up the like 5 peta. So the numbers was like 5 petabytes and we can buy it for roughly $1 million. That basically give us roughly $200 per TB cost for the initial investment. And for HDD-based storage, we can go even to like smaller footprint, like 1 peta only, because we don't need to buy all the capacity from the year one or from the 0 point, like it was shown on the previous slide. And we can, let's say, pay as you grow. So we can add capacity during our TCO term, and we can refresh it and so on. And basically, even for 1 peta, we have the number lower than the TB cost for tapes. It's 140 against 200 for LTO, and this number actually includes all kind of costs like servers, like on-site support, like networking piece, like software support and updates, and even professional services to launch the whole cluster.
And Dima, this is actually also usable space, which means it already includes the professional redundancy built into the storage.
Yes. And so it's not like apples to apples. So there are two great advantages. First one is usable capacity, and the second one is that actually the future capacity that we would add is cheaper than the capacity we can buy now. That also affects economics a lot, but let's discuss it during our further slides. I'm stopping sharing the screen, and I will send the link right now in the chat.
So basically, the point is that with the tapes, it's very difficult to do really pay as you go, grow as you go, if you don't correctly design your storage system from the very beginning. And from the very beginning, the initial cost can be really very high. And it is an important factor. Also, we're talking about this, that this technological state-of-the-art usage of the storage system should also be applied, which is extremely difficult with the LTO. So
I think this myth is completely busted, and we can proceed with the third one.
Yep, let's do so. So guys, this myth will be a short one because it has a compression. So LTO's hardware 50% compression gives twice more storage for the same money. What about this one, guys? Why do we disagree with this statement?
Well, so that's exactly also why we do this webinar, okay? So it is about this to be protected against some marketing noise which is done around the tape systems. I don't know why, but the producers of the LTO tapes, they are choosing to tell us this information which is on the tape. So I will try to show it. I don't know if you can see, but there should be 6.25 terabyte written.
Maybe just a little bit closer to your webcam.
Yeah, maybe it's better. I don't know. And so what I'm trying to
nice.
Very good.
What I'm trying to say here is that there is no other information on this tape. There's no information that this is 2 terabyte tape. Nobody is even mentioning anything. And if you even look at the box, the box also is saying that this is only 6.25. There's asterisks, but no explanation what the asterisk means, nothing. So why the producers of the LTO need to actually reach for that cheap trick to tell us that, oh, you know what, if you compress your data on the LTO, you will have better capacity. You can apply compression everywhere. You can apply it on any medium. It's not only LTO feature, right? And this is really strange and very confusing, to be honest, when you look at the product and you think you are buying 6.2 bytes.
I think that it's very strange since if we will look at the files that you have probably on your PC, and the most space consuming probably video files, and you can't just easily compress them, especially if, twice or even more. And the current practice for HDD drives that is real capacity is shown. Can you see the drive? So this one is really big. It's slow, it's 20 TB, but I never saw the tricks like that. So this drive would be 50 TB being actually 20 TB. So it's just a very, very strange practice. Since I'm totally okay with discussing the usable capacity, we previously showed you the TCO tool. So usable capacity is good for all kind of calculation because it's already implies the redundancy penalty and the difference between the raw and the usable. But in case you apply usable term for like tape or HDD, I don't think it's like fair. And actually, if the compression rate is not true, then the speed rate is not true as well. And here we have another problem and another myth. So this is just a slide to show you the devices that we actually showed you. And if we would compare it's apples to apples, so we need to stick with raw capacity, not usable with like...
Yeah, just please be careful there. When you choose your storage technology, make sure that somebody accidentally in the contract didn't put the capacity, including 2.5 compression in it. Okay, it's not nice, but there are some producers which put only this information, right? And okay, so the speed also is affected, of course, because the speed is also given with compression. And on the next slide, we are actually referring about this, right? We are referring to...
Yes, that's the myth number 4.
Yes, so...
Yeah. So let's go with this one. So yeah, but first of all, thank you for explaining the previous one. But I'd like to also ask you about backups, because I think it's hard to disagree that LTO is really good for backups. So I mean, LTO includes snapshots, recovery, and testing, as you can see on this slide. And what do you think about this one? And if you disagree, is there a way to benefit from best practices for backups? Please, guys.
Let's start from the very beginning. You know, in our industry, there are 2 kinds of engineers. The first group is those who actually do backups. And the second group is those who actually check the backups on a regular basis. And that's why the transfer rate is extremely important for backup and the recovery process for LTO, because there is no snapshot feature possible to check the backup.
Yeah, well, I mean, one of the things is the snapshot, right? But actually, the funny part, which is, I have this 2 generation of the tape in front of me, and one is old one, LTO4, and this old one inside of the box, there's a label, right? And this label is giving a good practices about your data protection. And one of the points which is written here is perform occasional trial restores of your data. So how do you think, how much time would take for, I don't know, for 10 petabytes stored in your tapes to restore them in order to test them, to verify them? Well, I know the answer actually, right? And
how many days?
Yes. So if you talk about this private storage system, which I was talking before, LTO, which has like 7 drives included in it, it would take 45 days. 45 days to read your 10 petabytes, and then you can verify them, right? I mean, you verify them during this 45 days windows, but this is ridiculous. This makes impossible to apply the good practice about the backups into the system, which basically is too slow. And I want to point one more thing here, because sometimes people are saying, you know, but the tape is not slow, and they show you the speed only of one tape. They don't tell you what is the speed of your entire system when you have maybe 400 tapes. And they even try to convince you to buy the tape because it's faster than hard drive. And they say it is because hard drive is only 180 megabytes per second in good conditions. And the tape is like 300 megabytes per second, or with compression is even.
But we should measure the recovery process.
This is a lie. And we need to be very careful when we will accidentally enter into the multi-petabyte storage and
Dima, may you maybe continue what Neutrino was trying to tell us?
You know what?
Oh, he's back.
This is Zoom, right? It already crashed twice during our webinar, I believe. It's interesting. So, can you hear me?
I can hear you, yeah. And Dima is muted, so we cannot hear you.
Hi again.
Hi, hello.
So, what we was discussing when I like missed.
So I believe that I was trying to say that there are some good practices for the backups, and I don't know if you catch it. Yes.
Actually, we discussed that it's like takes around 45 days to transfer all the data. But I believe that if we are using HDD drives and some scale out software-defined storage, so we can spread the workload across the different HDD drives, and probably it will be like several times faster than LTO actually. But one important thing here is that for backup and recovery process, we don't need to actually transfer all the data. We can use the snapshot feature, and we can make the snapshot instantly. And probably the most consuming action would be like typing the command.
Yeah, I'm sorry, Dima, to actually interrupt you, but I actually believe that we should always do the verification and test of our backups on the snapshot. We should never do it on the real storage. So actually, this is must-have in the industry right now. You don't touch your original backup data. Everything what you need to do on them, you should do on something which, if accidentally somebody deletes something, it will only affect snapshot, right?
Yes, that sounds reasonable, but there's no such feature for LTO legacy stuff.
Yeah, okay, guys. So I believe we already know what may be wrong about cold data archive, what are those misconceptions. But maybe Dima, what is an alternative for a good, for proper, reliable, and cost-efficient cold data storage?
So I like this slide a lot. I call it promised land, or the land of milk and honey. And of course, there are plenty of advantages of LizardFS cluster against legacy infrastructure. And aside from the zero downtime hardware refresh conception that we discussed, and snapshots and cost advantages, there's a clear path on how to migrate from LTO to LizardFS cluster, right, Piotr?
Yeah, I mean, well, it is easy to be done because LizardFS is compatible with almost any storage technology which is there. It is also because we are actually a file system, right? So, and yes, the migration is smooth. If somebody have a need to stick with the other storage solution, at the same time start using the newest, the modern way of storing the data, it is all possible even to mix it for a while.
That sounds good. And actually, there's another topic I would like to touch during the discussion. Previously, one of our customers had a very, very dense rack with 8 petabytes inside. It was several years ago. It was like the most dense drives that were available on the market. And what I can see that right now we can fit at the same rack 8 petabytes, 16 petabytes, and it will use the same amount of electricity, the same amount of server units. So the idea is that data center costs for growing capacity is going down, and actually the TB cost for HDD drives is also going down. And the drives becoming bigger and bigger. Like a year before, the most efficient capacity was 12 TB from the perspective of TB cost. Right now, it's like 14 TB drive, and I believe before the end of 2020, the most efficient drive will be 16 TB. So it's like typically 1 or 2 steps back from the maximal capacity. And if we are using the bigger drives, actually we can save a lot, and the future capacity always costs less than the current capacity. And there's a like special technology like SMR drives that I showed you before. So the size of the drive is 20 TB already. So using these drives, we can drive the TB cost down even more, actually. So that's the idea. Some of the cloud players adopted these drives recently. So you can find the news about Dropbox. They adopted these drives and using them in the infrastructure. So.
Okay, so thank you very much, guys. I believe now we know really much more about cold data storage. On this slide, the next one, I'd like to show you what are the next myths that we would like to discuss. And the question to our audience, because we haven't come up with the idea which one would be the next one. We just have these 4 ideas. So please chat us, email us, call us, wherever you wish, and tell us which topic seems to you the most interesting so that we know which one will be the next one. I'll just read it out loud. So the ideas are, the myths, I mean, yeah. So scale up is cheaper than scale out, the first one. The second one is replicas are always faster than erasure coding. The third one is the cheaper server, the lower TCO. And the fourth one, the Groundhog Day for data migration. Yeah, like the movie with Bill Murray about never-ending process of data migration to newer storage systems. So yeah, so please email us, chat us, wherever you wish, let us know what you think will be the best one for next webinar.
So the idea is that we would like to talk about these myths in the way that they are really the myths, that it doesn't need to be this Groundhog Day in your data center anymore. This is a myth. With the technology, we already are much further.
Okay, so and that's the best moment to start our Q&A session. And I can see that there's one question on Q&A, but I can check this because I'm sharing the screen. So Dima or Neutrino may be able to check that.
So the question is about that the warranty term is the same for HDDs and for tapes, but the tapes in general has a way lower fail rate that is typically under 1%. And for HDDs, we can imply that a higher failure rate, like typically above 1%. And the question is how it affects economics, and that's the question. So first of all, we can refer to some data, maybe the companies who are measuring the failure rate, like Backblaze, and not all drives are created equal. And if we will look at helium-filled enterprise drives, so the failure rate would be less than 0.5%, I believe so, or something like that. Piotr, do you know what is the numbers for tapes?
I'm actually even sure that for many years the original Hitachi and now Western Digital hard drives are actually having a fantastically low annual failure rate. Yes, so I believe I have some answer also for this question. Can I share the screen?
Yes, I will stop sharing the screen.
So I just want to warn everyone, because it's going to be just a rough calculation in spreadsheet basically. So I will just share my screen and let's see. And so this was by the way, that's my notes for this webinar today, just in case if somebody will have some more technical questions. And I have some links to support anything you possibly can ask me about. So, so annual fail rate actually exists for the tape, and they are producing an errors, and they can be even up to 0.3%. And this basically means that on the left side, I have some very particular LTO configuration here, and it is like 8 petabyte storage with 666 quantity of tapes.
Good number.
Well, I didn't meant it to be even number, just...
what is hell?
But there's a 7 on the point, so, oh, Jesus, okay, let's not do it.
Let's not mention Jesus looking at this number.
Yeah, okay, this is accidental. Maybe it's funny, I don't know. So, so basically it means that you can have actually in this kind of the storage, you could break up to 2 tapes, you know? And there's a lot of question which is coming about this. Like, for instance, is it possible to fix the tape? Yes, it is. There are companies which are doing it. But the question is how much time it takes to fix the tape. Well, usually it takes weeks, yes. And probably they are going to use some sophisticated hardware. Sometimes it's days, right? And at the same time, if I would compare it to the annual fail rate of the hard drives, which is 0.6% pessimistically, and this is the data for the last 5 years from the producer, which is using the helium technology inside, which basically, and this is the public data of Backblaze. I can open it. It's no secret. I can also, on the demand, if somebody wants to share the links later, just contact me after the meeting. So these numbers here are showing this. Actually, this orange line here does this hard drives. This orange line on the bottom is showing below 0.5% of the annual fail rate for many, many years, okay? So it is important to understand that the hard drive doesn't need to have a super high ratio of the failure. And another thing which is important, I already mentioned it before, answering this question is that, you know, we are using erasure coding, yes? It is like erasure coding, which is like for every 6 copy of your data, there are 2 extra copies, or not copies, but actually the checksums, which we can use to restore your data. And it basically means that you can lose any 2 servers at the same time, and the storage is still working. Servers, not even hard drives, I'm saying, yes? So, and there is of course the question, okay, so, but when you rebuild your storage system, how long does it take to rebuild it? And many people are terrified about this because they used to use this old legacy write matrix systems from the company, which are just not horizontally, but vertically scale. And the rebuilding of these old systems was taking a lot of time. But you know, if you have this kind of installation, like with 6 petabytes based on the hard drives, and you lose 1 hard drive, it will take literally 6 minutes to rebuild. 6 minutes. And then is the question, okay, but what if during the 6 minutes another hard drive will break? Well, I have calculated the probability of this is here. This is the probability is 0.003196, that during this 6 minutes, another hard drive will break. And by the way, this is okay if another hard drive will break, because we, when we define the software-defined storage, we allow for 2 things at the same time to be absent. And I don't know, this question for me is like a chain reaction. I could go on, but maybe there's another one before I will continue moving on. Is there another one question?
Yes.
Yeah. So maybe I'll read it out loud. So the question from Matthias, I believe, sorry if I read it incorrectly. So are tapes more environmental friendly than disks from power consumption point of view? Environmental friendly matter, yeah.
Well, it depends, because people are forgetting about this, that you can always switch off your hard drive. You totally can do it. As a matter of fact, I will show you something. I have here, this is something which is called marketing lies about LTO. And so many people when they try to sell tapes, they say, oh, you know what? Your hard drive can be eaten by the bug. Your hard drive can be burned. Your hard drive can be stolen. And the tapes cannot be. This is bullshit. I'm sorry. I mean, who said that you cannot put your hard drives inside of the case and store them next to your LTO tapes? You can do it. You know, it's a regular thing to do. Yes. Don't be afraid to switch off your hard drive and use them only when you actually want to make recovery tests. So you perform the backups recovery testing, or you want to upload the new portion of the data into your storage system much faster than you can do it to LTO. And so it depends. I have also another answer for the same question, if I can do. Okay, let's forget. Nobody wants to put hard drives in the boxes and carry them to the safe area. Okay, nobody wants to do it. Let's assume it. Then, you know what? There is something which software-defined storage solutions are giving you as system engineers for free, or not for free. It's built into this price of electricity, okay? And it is the possibility of using the course which you have. Let me search. Do I have a course? Oh yes, I have it, course. So if you think about this, that your average storage server has up to 8 cores, then if you build your 6 petabyte storage solution, you have available 304 cores, which you can use in your company for whatever you want to. It means this energy can be recovered, can be used for virtualization, for computation, for data mining. I mean, you name it, right? So it all depends. If you would just buy a storage based on the hard drive, never switch it off, and keep it always on and never use it for anything else, but occasionally upload your data, then it is less energy efficient than the tape, right? Or maybe not. No, it is, because the tapes have only 7 or 44 drives maximum when you buy these big libraries. So the maximum energy usage will be this 44 drives writing or reading at the same time. And here, basically, you have servers working almost all the time. In this case, how many servers I have here? This is like server capacity, usable disk in server. Yeah, I think I have here 38 servers here, yes. So this is like 38 one-use servers rack. And this, it's here, this is my cursor, right? And yeah, I hope I answered the question.
Thank you very much, Neutrino. Any other questions, guys? Maybe Dima or Neutrino, maybe you have something to add while we have this time, while people are thinking of the questions.
You know what, guys, I can explain why I wrote you do not be religious about it, okay? Because
yes, do that, please.
Okay, so the point is that this is so nice, you know, it's really nice, this tape, that many people think, you know, and it will never fail. It will go lifetime. And by the way, probably this is true for 95% all tapes, that they will last for the 30 years, yeah? The problem is that we cannot be religious about this. We cannot be just, oh, I believe that my tape will be in 95% of the ones which will never fail, yes? We should be realistic. The failure is going to happen, and the system which is used for storing the data needs to anticipate the failure. The failure needs to be daily routine for the system, and the recovery should be automated, and the user should not think about that anything is needed to be done. In Lizardfest exabyte storage solution of our customers, which we have, they are facing daily tens of drives being broken. And this is okay, because everything is fixed, it's repaired, and only when the box of, let's say, 40 hard drives is filled, they are being shipped on the warranty to the producer, replaced, once per month, and that's it, right? And it is only because they have very heavy usage of this hard drive, because there are many ways of extending the life and lowering the failure rate of your hard drives, which of course are part of the good practices about storing the data.
That is exactly the first myth we discussed with the 5-year term. So we should imply that we need capacity refresh and hardware refresh, since it's not the question whether this specific tape or HDD drive would fail at some point, but it's the question when. Mm-hmm. So at some point it will definitely happen, and we should get ready for this DR event. So we should design the solution that tolerate the drive or tape, that it can go down. Actually, it can happen, especially if you have huge amount of data, since the data we have now like created like for maybe past couple of years 90%. So we're facing this data growth trend, and we will face in the HDDs failure, tapes failure more and more. It doesn't really matter if it's like 0.3 or 0.6.
Yeah, I mean, you just remind me, Dima, that there was this, somebody asked a question, can I do the write over the tape? Well, you can and you cannot. It's like, not every write system can be applied over the tape system, but also then you need to remember that your capacity is not native capacity anymore, it's usable capacity. And so everything which applies generally on the hard drive storage or storage, any future modern storage which we are going to have maybe tomorrow, right? It could be probably applied to the tapes, but maybe it's not practical. For instance,
okay,
to have write 5, it's actually impossible. If you want to do it like
Nitrino, we have a question. I would like to address it. So what's the minimal capacity you should consider viable for LizardFS deployment?
Well, it's a few terabytes.
Please share your opinion, and I will share mine.
Yeah, so I don't know. Can you show the calculator? I mean,
yes, I can, but it's like a kind of just a model.
Yes. Well,
so just a model, and we from the practical point of view, it's better to have at least 4 nodes, and it's better to use schemes. Let me show you the schemes. Like okay, I will pick up slightly. So it's better to use erasure coding schemes +2. That actually, because we are implying that something may go wrong. Like we have a planned maintenance for 1 node, and then suddenly another node fails and going down as well. So it's better to have a kind of buffer for the DR events. And from this point of view, it's better to have like at least 4 or 5 nodes. Mm-hmm. And from the perspective of the best drive that we can use for storing the data to make it cost efficient, I think it's like it makes sense to talk about maybe 200 TBs, 400 TBs, since it's better to use the most efficient drives. So here we are using 1U chassis fully populated with 12, 14 TB drives that are the most efficient right now. So of course you can start with a smaller footprint, but this is the practical minimum that basically makes sense.
Yeah, so
but I think you can even run LizardFS with a single node, but it's not like for production.
Yeah, I mean,
but you can.
It is theoretically possible, and well, you know what? Actually, if somebody is interested to make some trial installations for the LizardFS, I'm more than happy to make 1-hour training about this individually for your DevOps teams or SysOps teams. So feel free just to talk to me about this.
Yeah, so there's email addresses, and you can reach us actually directly and ask questions, and we will address it in emails.
Are there any other questions? I see number 2, but maybe this is because I didn't read them.
Yeah, I believe all those questions have been answered already.
Okay, and also we kind of we finished the time which we scheduled for this, right?
Yes, yes, and we're a bit out of time even.
Yes, so I would like very much invite any of you to send your questions over later to us whenever you want to, and play with our calculator, which we have with DIAWAY, which actually can show you what is possible, right? Feel free to compare it. If you think that we make some mistakes with our webinar, please write it to us and let's discuss it. Let's understand the context and assumptions on which we were basing our mind-opening approach about fantastic technology which should not be used everywhere, right? And from me, that's it.
Yeah, and yeah, so as you can see on these slides, what we also would like to tell you is if any of you feels that he or she has enough experience or some knowledge to share, just let us know. We'll invite you as a guest speaker for our next webinar. So there is this possibility. If you have something to share, some knowledge, just feel free to email us on webinars@diaway.com. Okay, I believe that sounds like the end of today's webinar. So thank you very much for joining us today. That was a real pleasure. Personally, I do know much more about cold data storage. So thank you, Neutrino, and thank you, Dima, for bringing this knowledge to us. And stay tuned, guys. This is not the end, it's just the beginning. This is our first webinar in the series. So it will be more and better, of course.
We will send you the deck and the recording in a few days. I hope you joined our webinar.
Yeah, thank you again.
Thank you. Bye-bye.